This is an orthokeratology case where the patient has worn lenses for a little while now, but the cylinder part of the refraction is not being corrected completely. And if we look at the topographies, we do see that it's not purely right at the apex of the cornea. It does spread out a fair amount. And so I would recommend going to an oval zone for this patient to address the residual cylinder. So if I pull up the lenses that the patient's wearing right now, one for the left eye looks pretty conventional. The one for the right eye has a little bit of shape factor built into it. And so the power and the demand are a little bit different from what we would normally see. So for the right eye, I'm actually going to switch back to the previous iteration of the lens and kind of build off of this one to address the residual cylinder. The lens that had the shape factor built into it, I'm having trouble understanding the powers because even if we take that out, this is a lens where the demand is only 1.7 diopters or so on a minus 350 cornea and minus 176. Looks like we're a little bit steeper than we would be if we look at the left eye, for example. Pretty similar prescription, similar Ks. We're at about 8.5 base curve, whereas in the right eye, Wave thinks we ought to be at about a 7.9. So I don't know all the history behind this particular lens number 5 for the right eye, but I'm going to go with lens number 4 as far as demonstrating a toric zone. So we have our widths at 6.2 and 6.8. And what we want to do is in the vertical meridian have a little bit more treatment, so higher power or topo demand. And normally what we do is we also reduce the size of the treatment in that meridian so that we'll end up with an oval shape with a long horizontal axis, and that should mold out more of the patient's cylinder. So to do that, for a GSIM lens, we go to 50% mode, and in the superior meridian or the inferior, Wave will mirror it to the opposite end. Right now we're at 6.2 and 6.8, so what we're going to do is reduce this to 5.6 and 6.2. We want to note our initial power right now of 1.79, which should be the same as the horizontal, pretty similar, 1.72. So I'm going to drag this down to 5.6 and drag this down to 6.2. So now what we have is a lens where the IC in the vertical meridian matches up with the OZ in the horizontal meridian. And then because we were in 50% mode, Wave kind of puts it at an in-between position for the oblique meridians. Next thing we want to do is have a differential, a power differential. I believe the patient had about 3/4 of a diopter residual cylinder. Based on an original prescription of minus 125 cylinder, I'd probably build in a differential of 1 diopter. So in other words, if our power in the horizontal meridian is 172, we want our vertical power to be about 272. So still in 50% mode, you see that we can actually come down in power a little bit. So we'll come down. And coincidentally, we can get exactly 2.72. If we go to the inferior meridian, it should be exactly the same. So you can see in the quad view tear film tear layer display that the predicted fluorescein pattern we're going to get is slightly oval, and you can see also the back curvature of the lens is going to be toric within the optic zone of the lens. So I would incorporate the same designs into the left eye. We want a toric zone with about a diopter differential where the superior meridian has the smaller diameter but the higher power, and that should help eliminate your patient's residual astigmatism. So I hope this video helps. Best of luck with your patient. Thanks for watching.